Hey, what's up, everybody? Same shirt, different hat in the other way. Just trying to roll out a whole bunch of videos for everybody while they're out quarantined for COVID-19. I'm going to take a look at central angles and inscribed angles for you here today for all of you geometry fiends out there. So as we looked at the last lesson, we looked at the different vocabulary words and we went over central angles and inscribed angles. And one of the things that we talked about was a central angle. And the central angle is an angle with the vertex at the center of the circle, and its two sides are the radii. Okay, or I should have the radii. Okay, so if you're looking at this one, this here is a central angle because the center is there, and then when they draw your two rays there, core or radii here, it goes from the center to the end point, center to the end point. Okay, that's a radius, okay, and then two radii is there. So the sum of all central angles in a circle, going all the way around, is going to be 360 degrees. So what you have here is, here's an example. So angle ABC would be considered the central angle here because, again, the vertex has to be the center one, is the center letter in the center of the circle, so that's why it's ABC. So the degree of the arc formed by the endpoints of a central angle is equal to the degree of the central angle, right? So here they're showing you arc AC and arc ADC, or no, let's not get too far. So if they're telling you that this angle is 84, then this arc AC is going to be 84 degrees, right? And now, okay, so that's showing you this definition here. This is showing you that there, that the arc is the same as the angle. And then this is here. So if you had arc AC, which we just found to be 84, and then they wanted me to find arc ADC, well, all central angles have a sum of 360. So if I did 360 minus 84, that's going to be 276. Okay, so there you go there. All right, so now that's it. That's all I got for you here for central angles. So let's just practice a whole bunch of them here. So before I even get to over here, let's just explore all the different options that I have here. Okay, here we have vertical angles. Okay, angles that are across from each other that have this little x, and then these angles are equal. So those are going to be both 21 degrees. Now we just learned that a central angle and that arc created from it have the same measure. So if that angle is going to be 21, then this arc is going to be 21, and then the same thing happens here. Then we can do the same thing right here, right? So if I just blow this up for you, right? So if I just had the 21 and the 21, well, if you have this here, which is a straight line, we know all straight lines have 180 degrees. So if you subtract that, you're going to get 159 degrees. So this angle here is 159, which means this angle here is 159. Going back to my picture here, that means he's going to be 159, and he's going to be 159, which means this arc is 159, and this arc is 159. So that just kind of completes our circle there. So now I can go ahead and answer these questions. First, arc JK, 21. Angle JNM, so let's trace JNM, that's right here. That's going to be 159. Arc KL, okay, here's arc KL, we marked as 159. Arc JKM, so trace in that order, J, K, and M, and that was 21 plus 159 plus 21, which is 201. Okay, and finally we have arc MKL, so trace again in that order, MKL, right? So it's basically everyone except for 21. So you can do 159 plus 21 plus 159, or just say 360 minus 21, whichever you feel most comfortable with. Either way, you're going to end up with 339. So there you go. All right, so there is example number 1. Let's jump to example number 2. If you kind of keep that same thing in mind, what I've noticed is students always have a lot of trouble trying to figure out, okay, who's going to be vertical. What I always like to say is you kind of look for the x or look for a straight line. Okay, that x is going to give you vertical, which is going to be equal angles across from each other, and the straight line is always going to be 180, and that's kind of the dead giveaway one. So here I'm noticing there's not two straight diameters drawn, or there's that I can, or here's 1x, right? But what I notice right away is this straight line here, this diameter SV, okay, I see that there. Okay, I see they gave me an arc here of 72, so you can bring that in here. There's really nothing I can do right now with this 87 because that straight line doesn't really help me here. So the first thing I would do is I'd bring the 72 in. Then, again, we just talked about that vertical. Check out that x right there, okay, with those two diameters. So that means 72 can go right there. Then you can say, well, oh, wow, well, I can see right here, SV are these two angles here. So you can do 180 minus 72, and that's going to be 108 right there. Then you can say, kind of do the same thing. Well, oh, there's a straight line here with the 72 and the 87. Same thing kind of there. To try to get this little angle that's left inside there, and that's going to be 21, because 72 plus 21 plus 87 equals 180. And now you can go ahead and just bring all those out, since this is a central angle. So he's 21, he's going to be 87, he's going to be 72, and he's going to be 108. Now you can use those to find the angles and the arcs. So try to give it a pause, try it on your own right now, while I set up to write the answers down. So first one, angle. Okay, make sure you're paying attention in the difference between the arc and the angle. Okay, so the arc, you're reading the circumference, the outside of the circle. The arcs, you're dealing with the angles, you're dealing with inside, right? UXV. So let me find UXV. That's right here. Column 72. Now here it is. ST arc. That's right there. That's going to be 21. Then you're going to have WV, that's right there, that's 108. Then you're going to have TW, so here's T, and here's W, and then some people will say, well, how do I know if I'm going to go this way or if I'm going to go that way? When we're reading arcs, try to follow the order that they're giving it to you if there's 3. If not, you go for the minor arc. Okay, so if I went TW this way, it's going to give me a major arc. I'm going to read it this way and grab the minor arc. So 21 plus 72 right there, that's going to be 93. And then finally, okay, 3, I'll follow the order. So I'm going to go from T, then I have to hit V, and then I have to hit W. And that's going to go in this direction. T, V, W. Add 87 plus 72 plus 108, and that's going to be 267. Okay, here we go. Find the value of x. So if I'm looking at this arc JK and this arc 17x minus 41 created a semicircle. And what we know is that a semicircle, their sum has to equal 180 degrees. Okay, so now I'll just go ahead and do some math here. 5x plus 17x is going to be 22x. 23 minus 41 is 18, negative 18. Move this to the other side, so 22x is equal to 198. So x is going to be 9. Now you can go ahead and substitute that 9 into here and into there to get those values. So 5 times 9 plus 23 and 17 times 9 minus 41. So that's going to be 68 here, and then that's going to be 112 there. So there are my two angles. So first one, or two arcs. So the first one, JK, 68. Now the second one they asked for was MJ. Now MJ can be derived from this arc here, or that angle there, central. That is the same as this, which is the same as that, okay? Because vertical can carry across to your arcs. So he's going to be 112. Then they wanted LMK. Here's LMK, so I'm going to go this way. So you're going to grab the 68, the 112, and the 68, and that's going to give you 248. All right, so there's some work with central angles there. So let's jump over now to inscribed angles and see what we have here. So right here, here's a picture of an inscribed angle. I know it's an inscribed angle because the central angle is not in the center anymore, it is on the circle. So an inscribed angle is an angle whose vertex is on the circle with two sides that are chords, right? So they're not the radii anymore because they're not going through the center, it's just right there. So an intercepted arc is the arc that lies between the points of an inscribed angle. So right here, the intercepted arc is between the points that created that angle. And the degree of an inscribed angle is equal to blank the measure of the intercepted arc, okay? And that's going to be 1/2. So it's better to read with numbers than trying to read a definition. So for example here, if I said angle ABC was, say, 40, then that means that the arc is going to be double that and is going to be 80, right? So here's your arc at 80 degrees. So if I'm moving from the angle to the arc, you're going to double it. If you're moving from the arc to the angle, you're taking half. So the measure of angle ABC is 1/2 arc AC. And you can either move either way, okay? So you can either double it or half of it. All right, so now let's put that into here. All right, so here you have kind of overlapping arcs. Okay, so if two inscribed angles intercept the same arc, then the angles are equal. All right, so perfect example, angle ABD. So let me trace angle ABD. Okay, so now ABD, where's his arc? His arc is here, AD. What other angle hit AD? Right, what about this guy right here? Right? And that, we're going to call him angle ACD. Okay, so these two angles would be the same because they share the exact same arc. All right, so now let's do some practice with this. So remember, you're going from angle to arc, double it. You're going from arc to angle, half it. Okay. All right, here we go. Angle to arc. So if he's 113, 2 times 113 is 226. So that would be 226 right there. Angle PQR. So here is angle PQR right here. That was grabbed from here, which was 180 degrees. So now what's the rule? If you're going from the arc into the angle, you half it, so that's 90 degrees. And the last one here, now they want arc BC, right? They want this guy right here. So what we want to do is we want to be careful. So first, if I'm going to go out, you're going to double 47, that's going to be 94. So don't be careful not to write 94 like over here. They want this guy. This diameter is 180 degrees, right? So what you would do is take 180 and subtract 94. And then that's going to give you 86. Okay? So right here, that's going to be 86 degrees. right there, because 86 and 94 would give you 180. Right, so just be careful. Okay, continuing on. Okay, inscribed quadrilaterals. So if a quadrilateral is inscribed in a circle, so a quadrilateral is 4 sides, right? Then opposite angles, so say A and C and B and D are opposite angles, so they are supplementary, which means equals 180. So we just said it. We said A and C. So angle A plus angle C would give me 180. Okay, then you have angle B and angle D. So angle B and angle D are equal to 180. Now let's take a look at a practice problem here. So angle W is 5x plus 1. Write that inside, 5x plus 1. Angle Y is 13x minus 37. And then they want you to find angle Y. So if you look, these two angles are opposite. It's a quadrilateral. I have 4 sides. So I'm going to do 5x plus 1 plus 13x minus 37 equals 180, because they're going to be some supplementary angles. So let's do some math. So that's 18x minus 36 equals 180. So that's 18x equals 210. Just doing some math here, and that's going to give you 12. Just be careful, though. They didn't want x. They wanted y. They said y is 13x minus 37. So I'm going to do 13 times 12 minus 37, and the answer is 119 degrees. All right? So there's some work with some central angles, some inscribed angles, and some quadrilaterals. So the next lesson is just practice with these things. So I would suggest to maybe go on to the next page and to practice them, and then go to the next video and you'll be able to see the answers from them. Remember, all this work can be found at www.cimath.com under the Geometry tab. Like, subscribe, follow, notifications, all that fun stuff so that you can keep up with us.